Okay, we're looking at the projectiles mini-test question 3. So I've got a particle projected from a point on horizontal ground. So it's going to go up and then come back down due to gravity. The angle of elevation is 20 degrees and the initial speed is, let's change pen, is 30 meters per second at a 20-degree angle. And I want the greatest height. So the greatest height is going to be there. And what is special about that point is that's where the vertical velocity is 0. So it goes up, slows down due to gravity, and then that's the point where it then starts coming back down again. So I need to think vertically. So if I take up as positive, the initial velocity upwards is 30 sine 20. The acceleration is going to be due to gravity, and that's acting downwards. That's going to be minus 9.8. As we've said, we're looking for the point where v is 0 and I'm after the greatest height, so I'm after s. So I'm going to use the equation v squared equals u squared plus 2as. So 0 equals u squared, which is 30 sine 20, plus 2 times minus 9.8, so it's going to be minus 19.6. times s, and s is what I'm trying to find. So if I add the 19.6s, let's make sure my s doesn't look like a 5. So I'll add 19.6s over to the left-hand side and then divide through by 19.6. And that will give me the displacement, which is the greatest displacement. So it will give me its greatest height. So 30 sine 20, just be really careful how you enter that into your calculator. Make sure you're squaring the whole thing. So 13 sine 20 all squared over 19.6, and that is giving me a displacement of 5.3714, but because I used g is 9.8, it only makes sense to give that answer to two significant figures, so that's going to be 5.4 meters. Okay, then part B, I want the range of the particle. So you need to know what they mean by that, and basically they mean the distance it goes in the horizontal direction. Okay, so for this one, so if I'm thinking horizontally, because we don't have to consider air resistance, there is no acceleration, so it's actually constant velocity. So the horizontal velocity is going to be 30 cos 20. Acceleration is 0, so I could use suvat, but I can just use displacement is velocity times time. So displacement in the horizontal direction is what I want, but the problem I've got is I don't know what the time is. So I'm going to have to actually think vertically so that I can find how long it takes before it hits the ground. So I'll come back to that. So let's think vertically. So we've already said vertically the initial velocity is 30 sine 20. Acceleration is minus 9.8. I want to know the time here, so the time when it hits the ground. And what's special about that point, if I'm thinking vertically, well, it's where the vertical displacement is 0. It's come back down to the same height that it was projected from. So I'm thinking vertically, s is 0, so I'm going to use s equals ut plus a half at squared. S is 0, so, and t is just t, that's what I'm trying to find. So that's going to be 30 sine 20 times t minus, plus a half a, so that's minus 4.9 t squared. Could put that into a calculator, but I can also just take out a common factor of t. So either t is 0, which we knew it was because t is 0 right at the start there, and it's got its vertical displacement is 0 at the start, or looking at what's in those brackets, t is going to be 30 sine 20 over 4.9. You could, though, absolutely just have use your calculator to solve that quadratic. So if you use your calculator, A would be minus 4.9, B would be 30 sine 20 and C would be 0, and that'd be absolutely fine. Okay, so 30 sine 20 all over 4.9. Oops, didn't close my brackets. Right, so 30 sine 20 all over 4.9. So that is giving me T is 2.094000, right? So if that was my final answer, I would be giving it as 2.1. But because it's not my final answer, I'm working it out to use another equation. I'm going to give that to, just go for the 4 significant figures. I mean, if I gave it to 5 or 6, it would be the same because there's just a couple more zeros on the end there. Okay, and S is what I'm trying to find. That's the range. So I'm just use displacement is, velocity. It's constant velocity in the horizontal direction times time. So I've still got that answer in my calculator. So I'm just going to times that by 30 cos 20. And this I will then give to 2 significant figures because this is my final answer. So that's coming out as, that's coming out as 59 meters. Okay.